everyone. We are here at the AI Engineer World's Fair. We have the immense privilege of having Chris Lattner, CEO and co-founder of Modular, here today. I am Harper Carroll from Harper Carroll AI. I'm an AI educator with a background in AI, got my undergrad and master's degrees from Stanford in AI, and now I teach AI online. And we're also here with Ronald, AI engineer, and we're going to be asking Chris Lattner various questions. So I'd love to have a brief interview, a brief background about Chris, because Chris is a phenomenal human and has a spectacular background. So Chris founded LLVM, was creator of LLVM when he was a graduate student at the University of Illinois back in 2000. And then he joined Apple in 2005, where he worked on developer tools, and notably was the lead author on Swift, which came out in 2014. Then afterward, he worked at various processor and machine learning companies like Apple and Google, Tesla and Google. And Google, he was working on Google Brain, doing machine learning there. And then at Tesla, he was the VP of autopilot software. So he has a spectacular background. And then in 2022, he founded Modular. And Modular works on tools to make AI development more quick and easy to use. So combining the easefulness of a language like Python with the extremely fast processing of a language like C. So really excited to have you here. It's amazing.
Happy to be here too. You're embarrassing me, but
I really, everyone
I love
has
you
to know.
anyways.
I love you too. I mean, everyone just has to know, but I am just amazed. So thank you for being here.
Yeah, happy to.
So please tell us first, for those who don't know, a little bit about Modular and Mojo.
Yeah, happy to. So Modular is a company, we're about 2.5 years old. We really were founded based on this idea that AI was important. Hopefully that's obvious to the world now. Mm-hmm. But also the AI software was really bad.
Yeah.
And so it was this question for us, which is, if AI is so important to the world, then why is all the software so bad? And a lot of the folks at Modular, myself included, are kind of at fault for building that first generation of software that everybody's using. So sorry for TensorFlow and PyTorch and XLA, and so all these things are beautiful in their own way, but they all have various problems. And so a lot of what we set out to do is say, let's actually go build the next thing. Let's learn from all this history, let's learn from the technologies, what worked well, what did not, and let's pull together all of this into a simple and easy to use system that can scale.
Yeah.
Now, along the way, Gen AI happened, ChatGPT and things like this, that pushed everything forward. Mm-hmm. And so while we thought that we were kind of ahead of the world in terms of, nobody understood this technology and why it mattered in this way, I think the whole world caught up. Yeah. And now what we see is a lot of suffering out in the world, and we say our mission is to reduce suffering. Yeah. Maybe for those that are trying to get AI into their products.
Amazing. So tell us a little bit about Mojo, because let's go more in depth about what you mean by that. Yeah.
Yeah. Well, so actually, when we set out to build new AI software, what does that mean? Well, right now, what happens is that all of the technology that you run on, so pick PyTorch, for example, ends up being built on top of open source technologies, then on top of a whole bunch of software from some hardware vendor, and then chips. And if you think about that, chips, vendor-specific software, open source. You always talk about the open source stuff, but what about the CUDA libraries? What about the Intel math libraries? What about this thick layer of software underneath this? There's actually very different depending on which hardware you're running. Yeah. So if you're running on Intel chips, you're running on the Intel libraries, and they're amazing. They put 20 years of development into these libraries, or if you're on NVIDIA, you're running on CUDA. And it's amazing. 15 years of innovation has come out of this because of CUDA, but they're also very different. And so no matter where you go, hardware makers have to build their own software stack that's very specific to their hardware in order to get to the more interesting problems of PyTorch or AI or these things that they're trying to solve for developers worldwide. Now, for a developer, you flip it around, it's actually a gigantic mess. You have all this software underneath you that's just different. Yeah. Different because of history, different because of the original goals, different because they played forward from what their hardware could do instead of backwards from your problems to the silicon. And so what we decided to do is said, okay, well, let's actually tackle that problem. Right? And so you mentioned Google. When I said Google, I built and helped scale Google TPUs. Very large scale exaflop computers, supercomputers around training and inference, and wildly difficult to program because they're very advanced. And so we had to build an entirely novel software stack to do that. And so what I learned from that and from many other experiences was that all the implementations end up being very specific to one chip, but all the algorithms are the same. Everybody thinks they're smart, they're all reinventing the same stuff.
Yeah.
And so kind of over the course of many years, I've been investing in building compiler technologies like LLVM.
Yeah.
More recently, MLIR, which is a new compiler stack, which is very focused on these accelerators and things like this. It's been about stitching together and pulling together this industry.
Yeah.
And so in Modular then, you say, okay, well, let's actually go all the way. Let's build a framework. Now, how do you do that? Well, you need to be able to program, and we want to be able to unify all of this stuff that is holding it all together. But at the bottom, you write x86 code for an Intel chip, or you write NVIDIA SAS code for an NVIDIA GPU. So what is that nearest ancestor? Well, it has always typically been the CUDA APIs or the Intel Math Library APIs. That's where PyTorch, TensorFlow, everybody starts at.
Yeah.
Well, we had this crazy idea of what if we replaced the vendor libraries? Well, to do that, you need a new way to program these chips,
Right.
because there is
Just to
not
make
a
sure,
thing that exists.
these are libraries that are 15 years old, right?
15
so
years
they
old.
are mature,
Yeah.
they're stable.
Absolutely.
They're probably like optimized, like.
Like crazy. These are things like matrix multiplication libraries.
I use that. Well, let's replace those.
Yeah, let's replace
Let's
those.
replace
And why? Well, it's because, again, there's a lot of good in there, but there's also a lot of bad. There's a lot of
Right.
performance cliffs. There's a lot of things that don't work. There's a lot of D-types that don't work the right way. There's a lot of bugs that happen in special cases.
Right.
There's a lot of numeric differences between two chips that both have bfloat 16, so it's theoretically the same thing, but they accumulate differently into float 32. Like very obscure things, but they end up materializing into brokenness at higher levels of the stack that you can't control or explain or understand.
And just from my understanding, is it because like you focus on one use case that made it possible to rewrite the whole stack?
Well, so we start from the goal of let's do that, and so we did not start from let's build a programming language. That's a long way of saying that. And so,
Right.
And so what we built was a whole bunch of really fancy compiler technology,
Right.
very abstract,
Right.
to prove that we could generate performance that would beat Intel on their own chips and beat NVIDIA on their own chips. That's hard,
Yeah.
first of all, right? And then when we, as good scientists, we had a hypothesis. Let's have a hypothesis, then let's validate it. And so we did so in a way that only our team could do. Right? And so very low level technology, writing internals of compilers directly,
Right.
dark magic that no normal developer wants to do. Then we said, okay, how do we expose this to the world? And then we had a big problem, which is that none of the languages that exist actually could do this. Like you look at that, C++. Well, I mean, fine, you can make it run on a CPU. It doesn't really run on a GPU. You get all the weird things. Python, like everybody loves it. Really slow, does not run on a GPU, right? You look at Rust. I mean, people love it or hate it depending on who you are, but it doesn't scale into accelerators. And so what we saw, and what I've lived, is that all these accelerators broke all the assumptions about programming languages that came before. And so this is where Mojo comes in. Mojo is a solution to a series of equations, which is you say, AI is really important to the world. All the software is really bad. You have to make progress on this, in my opinion, you have to unify things from the bottom, from the
Right.
silicon, up. And to unify that, you need the ability to program in a very low-level way.
Right.
But our goal is to unlock this for developers everywhere. And so it has to be Python.
It has to be accessible.
And so how do you make it accessible? How do you make it Python, which Python cannot do this? How do you target hardware in a way that nobody has even dreamed of doing before? Well, you have to build a new programming language.
Right.
And so what Mojo is it's, again, a solution to an equation, which is
Right.
to say all the developers, effectively, are in Python.
Yeah.
People love Python. Python's not broken from a design perspective, from
Right.
a syntax perspective. Keep what's great about it. Let's take then this new very fancy compiler technology, which is, I've been working on compilers for a little bit. I've learned a thing or two.
Yeah.
Let's bring together this next generation compiler technology aimed at unlocking the performance that can beat vendor libraries. And that's dark magic, that's really fancy, but then by building a language, you can now expose it to developers in a way that they can participate in the ecosystem. It's not locked into the compiler.
Right.
And so what this allows is a very open, very newly hackable system that the world hasn't seen before, which is really cool, and it's what AI developers deserve, actually.
It's so cool. Like, this is going to completely change everything. You have gone in and taken this technology that everyone was using, and you rewrote it from the ground level.
Yeah.
And because of your history in compilers with LLVM, of translating kind of higher level code into more like almost assembly level code, to writing a programming language like Swift, like this is your entire life, to machine learning at Google and Tesla, this is like your whole life not whole life, but a lot of your spectacular work history coming together at Modular to build something that is so groundbreaking. Honestly, I'm like, if you don't, this is a big deal. So if you don't know about Mojo yet, you soon will, because this is a really big deal. This is going to change how everyone does AI ML programming. You won't be able to use the old system anymore because it just won't.
Well,
keep up.
we're not looking to.
Excuse me,
We're
okay.
looking to give people
Sorry.
new things.
I'm getting
that they
so
can
excited.
do.
Okay, sorry.
We still
you're right.
love
Let's be
PyTorch. We
cautious
still
about
love
what we
all
say.
the existing
We do.
things. Like
We do.
We hope it is useful. Like,
You're right. Yes. Like, I'll go
everybody
back.
can win. There isn't them versus like,
There isn't. Oh, I'm so
we love
sorry.
everybody.
We
but-
love everybody. I'm
but-
just
but
so
the-
excited
but,
about
But
this.
a different way of saying it is,
Yes, yes, yes. Thank
in
you.
many ways, Modular is kind of 2.0
Yes.
of many things.
Mhm.
And so
Yes.
have built LLVM. It's a very fancy, great compiler for
Yes,
CPU stuff.
totally.
Then built MLAR,
Right.
the way better than LLVM thing that then can scale to all the hardware.
Okay.
Right? Swift,
Right.
great programming language, love it. have learned many things,
Yes.
and so those things now channel into Mojo, and so Mojo is a very different
Yes.
language than Swift for very good reasons. And so being able to learn from these experiences, also PyTorch and TensorFlow, learn so many things. They're
Yeah.
beautiful in their own right.
Yeah.
They do so many things right. They also do certain things wrong, and
Yeah.
so it's not about any of these, like LLVM, like I love LLVM, it's a good thing too. I'm not anti-LLVM, but I want to continue to push the state of the art forward and keep moving things
Exactly.
forward and,
Right.
and making progress. And make sure to integrate with all these things, because
Yes.
being able to do that is super important.
Right. I mean, that's kind of the whole open source community, right? Is building
right.
on top of each other's work. And so when I say, like, it's 2.0, I'm not trashing the old language.
exactly.
Because, I mean, their work is what made our work possible. And, like, those drawbacks that we learned from how they did it before and how it was done before is how you were able to make, and
Well,
your team
it's
was able to make
it's all
this.
about like progress.
Exactly.
How do we build the world's best thing? And it's not
Exactly.
about looking backwards and being critical.
Right.
It's about,
Not at all.
you know, I'll pick on TensorFlow because few people want to defend TensorFlow these days, but it was started in 2016. The world is very different in 2016.
Because
Naturally.
we didn't have like generative AI back then. We didn't.
No, it does not.
There's a lot of things we didn't have.
We didn't have a lot of things. Like we've learned so many
Yeah,
things as an
yeah,
industry,
sure.
right? And so it's the thing with Modular that's really special is we have the opportunity to do this because you talk about how difficult this is, right? That is a thing, and you talk about battle scars and things like this. Modular is only possible because of investors that are willing to believe in us
Right.
for the long term, right? And we have over 100 people building for years to solve some of these fundamentally hard problems
Yeah.
and move the world forward. And that's not an opportunity you get every often
Yes.
or every day. And so
Yes.
being respectful of the opportunity is one of the reasons why we're so deliberate and we try to do things the right way and make sure that we're building into this in a way that is sustainable. And even though that takes a little bit more time.
And does it also mean that so are there like use cases where modular is not a great fit?
Yes, absolutely. So Modular is very focused on inference right now. And again, because of focus, we have to decide: are we going to do inference? Or are we going to do training? Our opinion is that most of the suffering is in the inference space, and so with the goal of minimizing suffering in the world, we're focusing on inference. Someday we can talk about training and things like this,
Sure.
but we're very inference focused. We're going from CPU to GPU. And so GPUs are where a lot of the pain is today, and so we want to spend a lot of time there. People ask us about other chips all the time, and our stack is designed absolutely to go do all the chips, but we're a small team, we need to stay focused, and most of the suffering is on GPU. And so, and GPU, I mean NVIDIA, by the way.
Yes.
Okay,
Yeah.
okay, gotcha.
Yeah.
Yeah. So if I download now, it will work like on NVIDIA,
So-
but not yet on Apple Silicon or
So we actually have amazing performance on Apple CPUs,
Apple CPUs. Yeah.
but we haven't
yeah.
done any work on Apple GPUs.
Gotcha.
So it's something the team's very excited about. This is one of the fun things about having this very hackable, expensive stack. They make these predictions that I'm not sure if I believe. That bringing it up would be way easier than anybody thinks is possible, but we have to stay focused. And right
Yeah.
now,
Yeah, that makes sense.
We have not launched our NVIDIA support, so it's coming in the next very small number of maybe even 1 month. So
Okay,
we'll see.
okay.
We'll see.
So for whom is this? Is this for like the AI engineer working at home or like a small team, or is it like for the big companies that like API providers There were a few here. One of our sponsors is Fireworks AI. So who is this for? Is this what's like the scale, or how much can you scale this solution?
Well, so it's super funny because it depends on how you break the world down.
Mm-hmm.
I don't consider the AI engineer to be just a big company thing. Right? So yes, big companies have a lot of AI engineers. They also have a lot of researchers. They have a lot of AI deployers. They have a lot of tinkers. They have there's many personas that flow into this, and I think many of the people in the open ecosystem wear those hats, right? And so they wear hats, and sometimes they're an open source developer, they're a PhD student. Sometimes they're a principal engineer at some company, and so I don't associate enterprise as being on the same axis of are you a deployer or things like this. I think it's actually fairly orthogonal, and so the way we handle that is we say Max is our framework. It's an AI framework designed for inference. Works with PyTorch, has native Gen AI support, and so you can decide whether you want to engage. Max is completely free, and so you can use it if you're a PhD student or whatever. It's great. You can use it at a company. It's awesome. We want people to build into this ecosystem. It's still being built out. Again, we don't have GPUs quite yet, but it's about to land. And then orthogonal from that, we have cloud products. And so we do support managed services. We do help people deploy. We do actually want to make people help solve their production problems. And so we can help on both of those axes. And that's also how Modular makes money, by the way, is that the framework and Mojo and things like this are very horizontal, and we want to see them go everywhere. And then we can help people in cloud.
Right. So the tools to develop and to run things locally,
That's right.
Those are free.
Yeah.
If you want to deploy it to like on a big large scale, then you have a solution for hosting different server.
And we can help people in
based on
AWS, and if you have your custom crazy Kubernetes setup and things like this, and so we can definitely talk. Yeah.
So a lot of our reviews are like Python developers, AI engineers. How do they start? I mean, what do they need to relearn or unlearn from what they know already?
Well, so it really depends on what your goal is. And so the way we kind of break things down is that there's no perfect way to do this, but PyTorch is really strong for training. PyTorch is really strong for deploying more traditional models or when you don't care so much about performance. But what I've seen in the industry, tell me what you've seen, is that when you get to Gen AI and you get to cost matters, what has happened is we've gotten this explosion of micro frameworks. And so what Max is trying to do is we're saying, great, let's help PyTorch users make PyTorch deploy better than it's ever done before. Let's also be the best thing for Gen AI, and we can provide native APIs. And if you want to be doing the next great page attention implementation, and you want to control things at a low level, Max can help you do that. And so we have a replacement for the NVIDIA driver, so you can control where your memory allocations go, and you can go completely nuts if you want to go down to the metal and you want to control this kind of stuff. Launch CUDA kernels yourself, or launch Mojo kernels on your GPU yourself, all this kind of stuff. But you can also intercept at the PyTorch level and just say, okay, well, I have an existing model, and go from there. And so what we do to help people coming into the ecosystems, we provide examples of both. And so you can go see our Llama 3 example. We're saying state-of-the-art performance on CPUs, for example, and so on your Max CPU, not your GPU, but on your Max CPU, we're faster than anything else that exists out there, including Llama.cpp and all the other things. If you want to use PyTorch examples, we also have PyTorch examples, and then you're in the PyTorch ecosystem, and so we can help you with both of those.
So is it like an importer? If I have a PyTorch setup, do I need to import things, change things, or how does it work? Can you explain it a little bit?
So we are not replacing PyTorch, we're embracing PyTorch. And so the PyTorch team has built a ton of cool technologies for exporting models. And so you've got all the usual suspects, including Onyx, so we support that, which is kind of cursed in lots of ways. We support TorchScript, and it's way more flexible than Onyx. It also has certain challenges. We support Torch Compile, and we support the export stuff, and so we support all the standard things that PyTorch supports. And so we love the PyTorch team. We work closely with them, and but we are not trying to replace PyTorch. It's owned by the PyTorch Foundation.
Yeah. So no changes, but you get the benefit of added speed
Exactly.
for inference. I mean that's where the focus is.
That's really our focus.
Yeah. Gotcha. Yeah.
Can you talk a little bit about how Mojo helps with full machine utilization?
Yeah, great question. So Mojo is a really different programming language than you're used to. So let me just frame this as an example. So often people don't think about it, but when I was a kid, you would have a CPU and you could do integer arithmetic, and then later you got floating point. And like, in other words,
those were separate like coprocessors,
they
right?
were different things.
You would buy them separately.
Yes, my first computer could not do floating point hardware, but
I bought one. Yeah.
But today, like you're on a Mac, like your Mac, the Apple Silicon chip has a neural processor, has GPUs, has CPUs. Within it, it doesn't have one CPU. It has 16 or something CPUs. Mm-hmm. The CPUs then within them have threads, but they also have vectors, SIMD. Mm-hmm. And so you think about programming this kind of machine. When you talk about an NVIDIA GPU, massive SMs, like all this complexity. Our programming languages don't have vectors. Like, how do you do SIMD? Like, that's 4x or 8x performance right there. Mm-hmm. Well, C++ still doesn't have a standardized SIMD extension. It's 30 plus years old, right? And so when you look at threads, threads are not a new thing, but a lot of people are still using pthreads. And so what Mojo does is says, okay, well, let's take the capabilities of the hardware, and let's make it super accessible at every level, make it really easy to get to vectors and threads and all this kind of stuff, and make it so that you can learn these things one step at a time. And so, and you can also ignore them when you don't care, because a lot of people don't care about performance also, by the way. But as you build into this, what you get is you get this layered ecosystem. And so now that layered ecosystem starts on CPU and fully utilize that. That's how you can beat Intel on their own silicon for performance. But then you see that Mojo scales into GPU programming.
Right.
Well, what that does is that enables you to take all the lessons learned in this ecosystem and then bring them forward into this new hardware. Beyond that, like, we hope we can go further, and we have ideas about what to do in other kinds of silicon, but it's about having these basic things that scale.
Right, so lots of tremendous cost savings, potentially.
Well, and I mean, that's one of the outcomes. And let me give you, in the programming languages thing, I know that many of your folks know what Swift is. I'll give you one simple thing that Swift didn't get right. And so it's the ability to have generic code where the generic arguments are not types. Mm-hmm. So why can't I say something where, one of the dimensions is n, and n is an integer, and maybe I have a fixed size array. So Swift still, I think, imports C arrays as these crazy tuples and things like this. Well, not having that one thing makes it very difficult to write metaprogram code, where when you're writing high-performance numeric math libraries and things like this, like, you have a lot of static information, you want to specialize it, but you also have lots of hardware you want to talk to. And so one of the cool things about Mojo is it runs on ARM processors and Intel processors and like all these different things, but there's so much complexity. I don't know if you know SSE and AVX and AVX 512 and AVX2 and all Neon and like all this crazy nonsense they've been putting in the silicon. And it's all very similar, but it's also different in important ways. And so Mojo allows you to write parameterized code instead of having to copy and paste code over and over and over and over and over again, which is state of the art.
Yeah.
And this is why you get major scale advantages. This is why you can attack new kinds of hardware in a new way, because you're enabling a specific, very low level kind of programming to be very easy.
So am I right if I assume that you only were able to do this because you created like the compiler for this,
Yes.
And all these optimizations are basically compiler level? Is that correct?
Well, so there's really a couple of things going on. Like, anybody theoretically could have done this.
Mm-hmm.
You have to be crazy enough to do it. And so the first question is like, why would you be crazy enough to build a programming language? Everybody knows that fails.
Mm-hmm. Yeah.
Right?
I mean, not only one, but in your case, like
several.
two, yeah.
Well, also OpenCL, like this
okay.
project. And so, but also some lesser known ones that are even more cursed. But so part of it is understanding when the right time is to do a thing and understanding fully what you're getting into. And being able to pay for it, being able to track the talent, being able to do the design work, being able to make space for the number of years it takes to build a thing, because these things are actually inherently hard. So there's that question. Right? The second question is, when you decide you're going to do it, how do you know how to attack the problem? And so part of this was we decided to control the design space. So why is Mojo a Python? Mm-hmm. Well, there are lots of reasons. That's where the community is. It also means you don't have to spend all your time bike shedding the keyword. Right? Swift, lesson learned, turned into let's have a pretty language. And lots of people can disagree about what pretty means. whether Swift is pretty or not. I think it's quite nice, but you can spend a huge amount of time on things like that really are not core to actually building out the ecosystem. Whereas if you say it's Python, therefore it's deaf, therefore like all these things are fixed.
You don't have to have that discussion anymore.
You don't have to have that discussion.
Yeah.
So you can really focus your energy, and you can say, well, okay, what are the places we have to be extensions to Python, instead of like, is it def versus fn versus func versus function versus stuff like this, right? And so like there are many of these kinds of questions that go into it. Then you say, okay, well, what is your problem? The problem is lots of hardware. Well, it drives specific technical objectives into the language. And so things like parameterized code, where you can have very general parameterization of these algorithms to make sure you get your matrix multiplication go real fast, because that's important for everything in AI, right?
Yeah.
And then you get into other things and you say, okay, well, we're doing a language. It's a rare opportunity to do something that can have an impact like that. How do we learn from things like Rust?
Yeah.
And so Mojo has a way better borrow checker than Rust and things like this, and brings a lot of the safety and performance and things like that people would expect from a modern language, just because you have the opportunity to move the world forward. And so each of these things go into this, and none of them are themselves enough, but it all is a blended set of.
So does it also mean that you can do things with Mojo that you cannot do with Python? Is there more to Mojo than just like Python?
Yeah, absolutely. So Mojo is a superset of Python. So Mojo's not complete yet either. So that's one thing to know. And so Mojo is itself, we're prioritizing the feature development from the hardware level up. Mm-hmm. And so we don't have all the dynamic features of Python yet, but we have functions and closures and the ability to declare things. We have some dynamic features, but we have really strong static features right now. And so the way to think about Mojo over time is we want to be good at what Python is, including all the dynamic things and classes and all whether they're tasteful or not. People do lots of crazy things with Python. But then instead of having to switch to C++ or CUDA or Rust or something else to do heavy lifting, you can just add a few types. And one of the big challenges that I've seen in the Python ecosystem is a lot of people have tried to take Python, which is an inherently dynamic ecosystem, and not just language, but also library ecosystem, and then have tried to say, well, let's make a sufficiently smart compiler that then makes it go fast. There's a bunch of these, by the way. Some of them are successful, and you can see 10x, 20x speedups on Python. We're saying, look, we will give the programmer control. And so if you want your integer to be fast, declare it as an int. And then it is predictably fast, in your control. It's not subject to a compiler being smart or not. It makes the compiler way simpler. It gives you as a programmer full control. You can actually reason about this. And it's simple. And so that is something that the Python ecosystem hasn't seen before. And that's one of the reasons why people love Mojo, is that they can understand what's happening. It's not like dark magic behind the scenes.
So is it a little bit similar? Could I say like Mojo is kind of the TypeScript? What TypeScript is to JavaScript is Mojo to Python?
There's tons of
would you object to that? Yeah.
It is correct in that TypeScript brought forward the JavaScript ecosystem, and so it's correct in that dimension. It's incorrect in that TypeScript runs in the same VM that JavaScript does, and so Mojo doesn't. Another fraught analogy is Objective-C to Swift.
Yeah.
So if you look at what Objective-C is a lovely language from a different era, by the way, also very polarizing. Objective-C was the Smalltalk object model on top of C.
Yeah,
right? And
forced
so,
onto C.
And so it was forced onto it, it was glued together because building a language was impossible. Objective-C was originally a preprocessor, right? And then it graduated into being a full compiler and things like this. And so what Swift was saying, okay, well, in Objective-C, you have this two-world problem of you have objects and dynamism, and you have C for control and power and performance. Let's build one language that can unify these two things together. And what Swift is, it says, okay, well, you can have dynamic classes, you can also have structs. Okay? And that works really well. Swift also said, let's fix the syntax problems. And so what you can see Mojo is doing is it's saying, kind of like Objective-C to Swift, is it's saying, let's solve the two-world problem. In the case of Python, it's Python and C. In all the different ways that Python talks to C, or Python and Rust, or Python and C++, let's fix this. Instead of switching the syntax of both of them, let's keep Python, and let's have it eat the rest, and the output is Mojo, and it's an extension of Python. And so from that perspective, it's actually very similar. A lot of the lessons learned from Swift come over in terms of the runtime, embracing the existing software ecosystem. And in Mojo, you can import an arbitrary Python package, even one you wrote, without writing bindings.
Yeah.
That's actually a really big deal. It means that you can bring forward the entire ecosystem without rewriting it.
So you have all the libraries that exist out there.
100%.
You can just use without any
Just use it.
issues.
And this is something that is very learned from the Swift experience as well. One of the things that we're working on now that will be getting done hopefully in the next few months is the ability to say, I just want to write so right now it's very easy to take Python into Mojo and use Python libraries in Mojo. And what we're working on is make it so you can write Mojo and just produce a Python library from Mojo.
Oh, okay.
And so you can say, hey, instead of Mojo being the driver, I want to just take an existing Python package and upgrade it and replace all C gunk and now just be able to deploy something written in Mojo into the existing Python ecosystem, which is one of the most requested things we've had from the very beginning.
That's a big
finally,
deal.
finally getting there.
Yeah. I mean, especially for the people like the Microsoft people out there, this is not like extended embrace like we've seen in the past. This is like giving back to the Python community as well.
That's exactly
this
right.
way. Yeah.
Well, and so what we've seen in our ecosystem is that Modular is very focused on this AI thing. I mean, I think it's pretty cool. I think you do too. But software is very horizontal, and so people ask.
In what sense?
Well, people ask us all the time, like, why aren't you building a GUI library? Where is your web server? Where is this and that and the other things?
Yeah, where's your web server?
We have a lot going on. We're pretty good at certain things. We don't know all the things, and so it's very exciting to see people who are building GUI libraries in Mojo, and they're building web servers, they're building training frameworks, even though Modular is not. They're building all kinds of stuff, which is amazing, and I love it. And so I as you say, like, I just want to see this go everywhere, and if people find it useful, that's great.
There's one thing you said that earlier is you talked about timing a little bit. It has to be the right timing to create, because I mean the idea to create like a new programming language for AI, that's a bold move. So what was like the point that kind of you thought like hey, now is the time to create a new language?
Yeah.
Because this was before Gen AI existed. That must have been right.
Yes, correct.
So what was that moment that's
So I mean,
epiphany you had?
It was a solution to a series of equations. It wasn't. So we started Modular at the beginning of 2022. Sorry, I'm getting old. At the beginning of 2022. Okay. We built for 10 months without a language planned, with no goal of building a programming language at all.
So why did you start?
It was about building very core, low-level compiler technology in MLIR and building an entirely new AI code generation stack.
Of course.
And what we were doing is we were writing the internal compiler IR by hand. That's how we did it. Right? Again, it was about prove that we could do a thing, and then if we can validate our goals, then yeah, we can solve syntax later. And then when we got through that, we said, okay, well, it's beginning to work. We believe in what we're doing. We have confidence in this path. How are we going to actually scale this? And we looked at, okay, well, you can use an existing language. So I built Clang, the C++ compiler. I know a lot about that. I know a little bit about Swift. I know quite a lot about Python. I know, there's all these things you go shopping and you say, well, what language can we use? And unfortunately, Clang, for example, started in 2007. Different era of technology. LLVM powers Julia, Rust, Swift, like all these languages. LLVM doesn't do GPUs. Right? It doesn't do the kind of technology, the accelerators we need. We need something designed for MLIR. MLIR is this broadly used compiler thing in the AI space. There is no language that targets MLIR. Zero. And so we said, okay, well, we can't shop for a language, so we can either create a language or we can use a domain-specific language embedded into Python or something like that, which there's tons of these things. But the problem with that is that they're always really inferior. They don't work right, they have bad debuggers, they don't scale correctly, they demo really well, but they don't actually, they're very difficult to use. And so we decided that, again, walking in fully understanding the expense and the complexity of building a language, saying, it's worth it. Like, AI is important enough to the world. It's being held back by not having these things. Nobody else is bold enough to do it, apparently. Because again, you look at
for good reasons, probably, I guess.
Well, yeah. I mean, you look at this. C# and Swift are the only two languages I know of that were actually built by megacorps in recent terms.
That is
Right? And so everything else was kind of built like grassroots, like gain steam over time, or like for example, Python, but also C, C++ came out of Bell Labs and things like this. So before, Swift was my nights and weekends project for a year and a half before I told anybody at Apple that it existed, by the way.
Oh, is that true?
So, yes. And so, and took a little bit of work to get Apple to agree.
You should do this like a second interview.
This.
Yeah.
Right? And so,
I want to hear that story.
And so I can tell you a lot of reasons why big corps are not excited about doing languages. Right? And so, kind of as a consequence of this journey, right, realize that this is not obvious to people, right? But there's certain things you can only do if you actually do that. And once you do, a lot of other things come out of that. And so let me tell you you know why it's cursed to build a language, and that's a terrible idea. Let me tell you some of the advantages of this. Is that you can fix some of the most fundamental problems in software. Right? That's actually a huge opportunity. You can create and give developers an opportunity to build into basically a greenfields ecosystem where all these things that, still work, so all the Python libraries still work, that's super important, but then people get cool new toys. Right? And this is lessons learned from Swift, right? Or you look at JavaScript, for example. JavaScript is a great example of it started as a cheeky way to script a web page. Now people are adding servers in it.
Yeah.
And so it was very natural that as languages gain steam, they form a developer community. The developer community builds libraries, and if you curate it and feed it well, and you build it in an open way, and you actually do the right thing, then you can actually get an amazing developer ecosystem. And because you give them new powers, like fancy metaprogramming features, the ability to target a GPU, like these kinds of things, then really, again, like Modular can't do it, but the ecosystem at large can really rethink some of the fundamentals that power software today. And to me, I think that's really cool. And exactly where that goes, I don't know. But fortunately, I don't have to. We can do our part, and everyone else can do their part, and we can all work together and be happy.
So can you explain a little bit like how does it look like in big companies? I mean, why is it that big companies can't or won't create these languages? And I mean, don't go into things you don't want to go into detail, because I guess there's a lot of politics involved in these kind of things. But on the other hand, it's you also have to convince investors, in your case, that what you're doing is something that, first of all, is something that's like bold but possible, but also something that will Google do it, will Apple do it, will anybody else do it?
Well, so remind me to come back to why BitCo doesn't do it.
Sure.
Because some people would disagree with my characterization. No, I'm happy to take that on. Let me tell you why I'm less worried about BitCo stepping on Modular, right? Because I think that's another very different question, and not everybody asks me this, but I think it's really important for people to understand. A lot of Modular coming into being was my frustration with BitCos, right? Because could have gotten that job at a big company. I've done so before. I've worked for a number of really amazing companies with amazing people. The problem with a big company is all about incentives. And so every big company these days is building their own chip, for example, right? I'm working on Google's. Amazing chip, wonderful chip. Very proud of that. It is at scale, very successful, amazing chip. They had to build their own software stack from the bottom up to support that one chip. They always have a new chip. The software team is always behind. They'd say they're understaffed. They actually have a huge team. But they also are struggling with the architecture of 2015, 2016, 2017, when, in this case, XLA was started. Right? And so the challenge is that you're never able to really do the big reset, because you always have a 6-month time horizon or maybe a 1-year time horizon in order to do these things. And some of these things are fundamentally very difficult. And so from a Modular perspective, I love all the big companies. They're all, we're friends with everybody. We love, even the cats and dogs. Like, we love the TensorFlow people and the PyTorch people. Like, it's wonderful. We love everybody. But the reality is that they're all incentivized to build their cloud, build their hardware, build their little brand, et cetera. They're not incentivized to build horizontal tech that developers can use, that want to be able to target multiple clouds, that want to be able to target multiple pieces of hardware, that want to be able to go where AI research goes. And this is why we've been very deliberate at Modular to align ourselves with the AI engineer, for example, the developer, the researcher, the production engineer, things like this, where we don't have a cloud. We're not building a piece of hardware. We love all the frameworks. We'll build our own cool stuff. If you want to use it, that's cool. If not, you can use the other stuff. Like, we'll just go where people want us to go. And that's a very different incentive structure than saying, I'm trying to actually convert people to buy my cloud. And so that's a very important aspect to know. And so therefore, we're very aligned with both our developer community, which is why people love Mojo and things like this, but also with our enterprise customers and things like this that need help, and they don't want to get kind of locked in. So now, on your point about why doesn't Big Co do languages, well, people disagree. There are, for example, at Google, there was Dart. There's there's Go. There is now this Carbon language, for example.
And these are just a few that Google has.
And there's probably 15 more that I don't even know about. So
11, 20 guys. So.
Yeah, and at Apple, they had Objective-C for a long time. They're very proud of it. And so it is not true to say that Big Co cannot produce a programming language. But what I will say is that my opinion is that you need an intersection between strong leadership, both in terms of vision, but also in terms of engineering, architecture, and things like this. And so if anybody's building a programming language for the first time, it's a very messy process, and there's a lot of things that you learn from that, and it can be very fun, but being successful is not obvious, and you have to make certain trade-offs. And so I can talk about some in Mojo if you want, but you have to be very deliberate about that, and often first times have a lot of challenges, including Swift. Swift had a lot of problems. That wasn't even my first. The other thing I would say is that within a big company, you have incentive structure problems with getting people to make upfront big investments. And so Swift, I started in 2010. It was launched in 2014. First year and a half, it was me alone working on it. Okay, getting it to the point where
one person.
In nights and weekends. I had a day job, by the way. And then I told management about it. They're like, I guess you can have a couple of people on your team work on it as long as it's not a big distraction. Make sure you get your job done, right? And
so your job was something completely different than...
And so in the case of Swift, it was about 3 years into its life cycle before it got to the point where, it went from one person to like 3 or 4 or 5 people that kind of dabbled in it part-time to saying like, okay, there's something that's really interesting that we could do here. And to me, that there became a very important set of decisions, and I don't want to share everything, but like Apple makes very deliberate decisions and wants executive reviews on important directions you go, as do many companies, right? And so one of the set of challenges that I had to overcome in getting Swift to happen was not technical, it was getting management to agree, which they did. Apple's amazing and bold, so by the way, and so I think Apple doing it is also a testament to Apple, but I had to answer very specific questions of, why not make Objective-C better?
That's a fair question, I guess. Yeah.
Right? And the answer was, and if you go look at what happened to Objective-C between 2010 and 2014, it got way better. It got automatic reference counting, it got literals, it got modules, it got tons of features.
Yeah.
And a lot of what that was doing is that was pulling Objective-C towards Swift. So when Swift was coming out, it was less weird.
Now these things make a lot of sense,
cool.
but yeah, there was like an acceleration in
But also modules.
Never knew.
But modules, for example, was what allowed Swift to be able to import an arbitrary Objective-C thing. And so a lot of it was, the development work on Swift was about making Objective-C better. And so we said, yes, we can make Objective-C better. And they're like, well, why do we need a new language if you can make Objective-C better? Another good question. Right?
Yeah.
And the answer was pointers. You can't take pointers out of Objective-C and still have it be Objective-C. You'll break entirely the entire ecosystem.
This is about safety.
And so safety, all this kind of stuff became the reason why you need to have a break from the past. Okay. So then there became, again, I'm explaining this as a linear series. Trust me, it was way more messy. People expect progress to be a straight line. Progress is actually this, by the way,
but the story sounds really like
I'm making it sound really
no,
like it was no stress. Like it was a series of very easy
walk in the park, walk in Apple Park.
Again, massive kudos to Apple leadership. Right? Another very important question is you say, okay, well, we could have a new language and that would solve pointers and safety and things like this. How do we know we're not going to split the ecosystem in half? That's actually the worst possible thing that could happen to the Apple developer ecosystem, is have two ecosystems, or they instead of one. Like that's actually a major problem.
Like the Apple II versus Macintosh.
And so you have to overcome that. And then you realize you're getting a lot of pushback from very senior software people, and you have to understand why. Well, it's because, and they would say things like, I don't understand, Objective-C is what made the iPhone possible. We don't have a garbage collector. We don't have it like the JVM. Like Objective-C is what made the iPhone possible. Why would we change that? It has the blend of dynamism where you need it, performance when you need it. Objective-C is perfect and wonderful. Like this is what has made Apple successful. And then you realize, well, they grew up as a software engineer writing Objective-C code for the last 15 years. And so what Swift represents is it represents an invalidation, not literally, but it feels that way, of everything they know and learn, and a lot of the managers are not writing code.
Yeah.
And so what Swift means is that they will never have the level of expertise that they have now, and that's actually very intimidating. Right?
It's a big threat for their statue and the job, basically, the job security.
That's right. Yeah. And so once you understand that, again, I'm fairly dense sometimes. I try to learn, but I get. but when you realize that, then you can kind of understand, and you can meet your audience where they are. Then you get into the we're again at Apple, who I have a tremendous amount of respect for. Apple says, look, if we're going to do something with our community, we have to support it. We have to make sure it's good. By the time Swift launched, by the way, only about 250 people at Apple knew about it, most of whom work for me.
Yeah, that was like the big thing, because I was there actually in 2014, like at the keynote, and it came out of nowhere because there were absolutely no rumors. Well, I mean, yeah, but most of the things, we all know like the Mac rumor sites and all these sites. Yeah. I mean, a lot of things leak from Apple, whether they want it or not. Things leak.
Well, and
but this was a complete surprise to everyone. Everyone's like you could hear like
the pin drop.
It was like, oh, what?
But the flip side of that is that by the time it launched, only about 250 people at Apple knew about it. We had people under NDA, and so there was like a reason we know this, which meant that virtually all the software engineers at Apple had no idea, and they were also not very happy about it, because now suddenly, why weren't they asked? And there's a whole dynamic there. But anyways, you come through each of these things, and each of these improbable challenges you have to face are all really good questions. And so why aren't big companies able to make certain decisions? Apple's really unique, right? Apple is within Apple there's a principle. It's called the culture of debate. Like at the right levels, there's an openness to be able to talk about hard things and work through the issues and like really wrestle some of these things in ways that other cultures I haven't seen, right? And so you have to kind of have this combination of good market understanding, good product sense, the technology, the leadership. I had built a reputation within Apple that people kind of trusted me because I'd done some good things before. It wasn't like my first thing, and built up the team, the expertise, working on other projects, and so like it was really a very special thing that only Apple could do. And you kind of have to get all that together in order to be able to do these things in big companies. And so it's not impossible.
Mm-hmm.
It's just very challenging.
Yeah.
So I don't know.
Amazing.
Awesome.
Should we wrap up?
Yeah.
Well, thank you so much for coming, Chris.
Yes.
This was a phenomenal discussion.
I hope this is useful. I don't know. I mean, I didn't prepare, but I have plenty of more stories for you.
Yeah. Well, it seems like it'll be pretty seamless for people to migrate over.
Yeah. So I mean, check out Mojo. It's freely available. You can download and play with it. The community is amazing, doing lots of cool stuff. We have every other week we have a community meeting, so you can like join and chat and talk about cool stuff. We invite presentations from community members working on cool things. Lots of contributions on GitHub, which is really cool. And so we're maybe not like we're still tiny, and so we're trying to grow into supporting the entire ecosystem, but we're trying really hard. And
talking about growing, I mean, I saw you mentioned on Twitter that you're hiring.
Yes.
Any particular things you want to share with
Absolutely.
the audience?
We're hiring a wide range of roles. Cloud, product manager, compiler engineer, AI engineer, machine learning kernel, lots of different kinds of roles. If you go to modular.com, you can find us, and you can see we have a careers page in the team section, and so there's a bunch of different positions there. Project manager, lots of different kinds of roles, and so we're growing quite significantly. So and I have to say, it's a super exciting time in the industry. It's a super exciting time for us as a team because we've been building these really obscure low-level things, and everybody's like, "You're doing what?" and now it's to the point where people are like, "Oh, wow, that's actually useful.
I get it.
Oh, you run Llama 5 times faster. Oh, okay, that's cool." And so you're kind of mapping into you're building up into the space where people actually get why it's important, and why it's important to people.
That's so cool.
So cool. So anyway, so thank you for having me.
Thank you for
Thanks
being here.
your
Cool.
time, Chris.
Cool. Okay.